Hello everyone, welcome to the course on Instrumentation and Process Control. Myself Nidhi Mehta, Assistant Professor at Chemical Engineering Department, LJIET Institute of Engineering and Technology. So, let's just start with today's topic, which is pH measurement. Before dealing with today's topic, let us just give a quick recap of what we have covered in our last session. So, in our last session, we have covered what do we mean by humidity, why humidity is affecting our process and our day-to-day life, what are various methods to deal with humidity, and we have also seen that how you can deal with humidity. Correct. We have seen what are the advantages and what are drawbacks of humidity measurement equipment. In today's session, we will deal with pH measurement. So, when the term pH measurement comes into our mind, the first thing which we understand is the pH scale. Correct. We only are aware about what is pH scale, what is range of this pH scale, and what are the various sections in this pH scale, right? We know that there are basically three broad sections in this pH scale, which are classified as acid section, neutral section or alkaline section. So, as you can see in this particular picture also, I have listed all the three sections or category of pH measurement, correct. So, from the range 0 to 6, it is termed as acidic, right. It is under the range of acid. The pH scale of 7 represent the neutral range, whereas from the pH range 8 to 14, we are calling it as alkaline, correct. Why it is so? It completely depends on the chemical behavior or chemical bonding of that particular substance, which varies from substance to substance, and due to that only it is in different level of pH scale. So, in this particular scale also you can see there are different substances which are present in different scale of the or different point of the scale, correct. So, if you can see water, there is a bottle of water which is kept in the point 7, which is neutral. So, it is quite safe to drink water, right. There is a tomato which is kept in the point range of 4, which is acidic in behavior. We know that it is having some sour taste. So, due to the acid present inside tomato, it is considered to be a sour, and that is why it is put there in the range of acid. So, it is generally in the range of 4 to 4.5, correct. As you can see in this picture also, I have listed that when you measure the pH of acid of tomato puree, it comes to be 4.15 or nearly 4 to 4.5. So, these are basically different pH measurement scale or devices which are commonly used in our day-to-day life or even in our industry. If you just recall the memory of the RO plant which is in our home, right. Even we are determining the pH range of water coming out of our RO plant, right. Why we are doing so? Because we just need to ensure that whether it is safe to drink or whether it is safe to consume or not, correct. Now, coming to some basic knowledge about pH. So, pH is basically the method of measurement of hydrogen ion concentration, correct. So, we are just focusing on hydrogen ion concentration which are present in our solution. The alphabet P which is present in the word pH will represent the negative common logarithm, correct? And the alphabet H which is in capital form or in uppercase represent the element hydrogen in our pH scale. So basically pH is negative algorithm measurement of the number of moles of hydrogen ion which is present in our solution. So by measuring the pH we are basically determine the concentration of H plus ion in our solution, correct? And as pH is measured on a logarithmic scale, if you increase 1 unit, so 1 unit increase of pH correspond to decrease in concentration by 10, right? It will just decrease by 10 factor in the scale. So why we are dealing with pH measurement in chemical engineering? So I just want to discuss few important sectors and few examples where pH measurement is quite essential. So the first example is food industry, correct? As a chemical engineer, we are also dealing with manufacturing, packaging and prevention of food, right? So whenever we are dealing with any kind of process in our food industry, it is quite very essential to check its pH, because sometimes we want our food to preserve, right? We are keeping or we are adding some kind of preservatives in our food. So we just want to ensure that adding those preservatives into our food does not change the taste of our food and it keeps that food safe enough to consume. For that we must ensure that the pH scale or pH range is proper, correct? So we always need to know the pH of our food which we are manufacturing, which we are packing or which we are preserving, correct? For an example, if we talk about an orange juice, so whenever we are extracting orange juice from the fresh orange and then we are adding some kind of preservatives in that, we ensure that after adding preservatives also, the pH range remain in that safe acidic zone to consume, because that acidic taste only which will give it a sour taste, correct? So it is quite essential. Next is our pharmaceutical industry. So in case of pharmaceutical industry also, determining pH is quite very essential in each and every step. It is just because in our body there is a quite range of pH varying from 1 to 8, right? Our body is having a different pH zone in different parts of our body. The most acidic portion is our stomach, right? So whenever they are manufacturing drug, they ensure that they make it in such a way that it is quite easy to digest in that particular portion and it can provide instant relief to that portion of our body, right? Even if you talk about environment, in case of environment also we are dealing with wastewater. So in wastewater also, after treating wastewater, we are determining the pH of wastewater to ensure that the outlet water is safe for water bodies or for all the water creatures which are living inside the water, right? Because there are few aquatic animals or few aquatic creatures which can only survive in the pH range of 1 to 5. So, we must ensure that we should not exceed the pH range which will be harmful for that creature. Correct. So, now let's just start with measuring of pH. So, first one is measuring electrode. As you can see in this particular picture, and it is quite obvious equipment. So, you might have seen and used this equipment in your laboratories also. This is known as measuring electrode. In case of measuring electrode, what we are doing is we are having two different electrode. One is our reference electrode and one is our measuring electrode. Correct. So, measuring electrode is having a buffer solution of constant H plus ion, and it is having a silver wire connected to it, which is then dipped into the unknown solution, and there will be a reference electrode which will be kept into the solution of reference solution. So, once you put both the solution in different form, it will generate a potential difference, and due to that potential difference, there will be generation of voltage. As you can see here, this will be more easy to understand. There is a reference electrode which is on the right side of this diagram, and there is a measuring electrode which is on left side of the diagram or figure, right. As you can see in the measuring electrode, there is a silver wire which is connected, and we have put the measuring electrode in the buffer solution of 7 pH. Correct. Now, coming to the reference electrode is having a silver wire again, and it is being dropped into a sample where we need to determine the pH. We will be connecting both the electrode with an connecting assembly, and once we connect both the electrode, due to potential difference in both the assembly, there will be a flow of electron from one point to another point. And due to this flow of electron, there will be potential difference which is generated, and that potential difference is then reflected in our voltameter. And this reflection in voltameter is then converted into the pH scale. Correct. So, this is how our electrode work. Next equipment which is used is reference electrode, which is also known as calomel electrode. In case of calomel electrode, the calomel electrode is also known as saturated calomel electrode, which we also write in the short form as SCE. This is basically a reference electrode which is based on the reaction between mercury and mercury chloride, as you can see in this picture also. Now, let's come to the picture here. It is having a wire lid which is a platinum wire. So, the calomel electrode consists of a platinum wire, and there is a hole which will allow the drainage porous plug to pass through it. Inside the electrode, we are having mercury and a mercury chloride solution. Correct. So, now in the bottom of electrode portion, you can see here it is having a porous plug which is made up of salt bridge. So, in general, the electrode is normally linked through this porous salt bridge, right, or porous membranes to the solution in which the other electrode is being immersed. Correct. And the electrode is normally connected via this particular solution. Coming to advantages of pH meter. Now, let's just discuss what are the advantages of using pH meter. So, the measurement of pH is basically important to determine the concentration of H positive ion in our solution, right? We are using pH meter to determine the amount of pH or H positive ion in our solution. Next is for chemical reactors and scrubbers, they provide indication of solution used whether they are acid or base. So, depending on your need, you can select which kind of solution you need. Next is the meter find major application to correct the hypochlorite concentration for oxidation reduction potential, correct? And even in the wastewater plant, microelectronic laboratories and pharmaceuticals, as I already discussed, it has a huge application of determination of pH. Now let's talk about what are advantages and disadvantages of using pH meter. First advantage of using pH meter is that they produce reasonably good and reproducible measurement, right? You can again and again use pH meter and they will give exact result for the same solution. Measurement of some solution up to 4th decimal place is even possible due with the advancement in pH meter. We can even determine up to 4th decimal place the acidity or basic behavior of any solution. Now what are the disadvantages of using this pH meter? So these are quite slow to register, right? Sometimes the results are quite slow, you cannot register that. Even there is an temperature influence the output result greatly, so we just need to give temperature some compensation. If there is change in temperature in any solution, the pH will have a drastical change in that particular solution, right? So if you change temperature of any solution, then there will be a change in pH of that solution also. And if there is some kind of deposition on the glass, then it will definitely affect the results, right? So these are the advantages, disadvantages and equipment which are used for pH measurement. Hope the topic is clear. Thank you.